Chapter 2, Atoms and Elements. So, your pencil, if you have one, has graphite in it. I know they're called lead pencils. There's no lead in your pencil. It's graphite. If you took a piece of graphite from your pencil and you cut it in half, and you took one of those pieces and cut it in half, and took one of those pieces and cut it in half, how far could you go? Assuming that, as things got smaller and smaller, you actually had a knife that was small enough to cut it in half and that you could see what you were doing.
Forever.
Could you do it forever?
Yeah.
Well,
Good technology too, yeah.
actually, you can only do it until you get down to 2 atoms, and you could cut those 2 atoms apart, and then you end up with a carbon atom. And you cannot cut a carbon atom in half, not even with an atomic-sized knife. There is a smallest particle. Have any of you been to Legoland? Anybody? Yes, thank you. So Legoland's this awesome place, but they have all these world landmarks, like the Taj Mahal, made out of Lego bricks, right? And it's not life-size, but it's pretty big for a Lego structure. So if you took that Taj Mahal and started taking it apart, could you take it apart infinitely? No, you could only get down to the smallest Lego bricks. You could get down to individual Lego bricks, and then you can't take those apart, can you? In a substance, you can get down to atoms, but you can't go any further than that. The word atom comes from the Greek word atomos, which means indivisible. So it's the smallest indivisible particle. You take matter such as the carbon and graphite and you cut it in half and cut it in half. You get down to the smallest piece, and if you manage to smash an atom into bits, which is possible, but you can't just cut it, it wouldn't be carbon anymore. The smallest piece you can get to is carbon. All matter is composed of atoms, and so we have to understand atoms in order to understand matter as a whole and understand what it does. So, in the 1980s, and again, I'm not quizzing you on dates or historical names or anything. Binnig and Rohrer at IBM in Switzerland did some work that led to the development of the scanning tunneling microscope, or STM. And the way this works is really cool, because atoms are so small that even with the highest, most powerful optical microscope, you can't see them. The limits of optics are such that you just can't see them. And so how can you visualize or see electronically an atom? And this is how they do it. So they have this electrode tip, and they pass a current through this that goes from this tip into the substance being examined. And a computer moves the tip so that the electric current is constant. When the current is constant, because that tunneling current that's jumping across empty space, that current is very sensitive to distance. So if we keep the distance the same, then the current is the same. And so we can see, is it the same or not? And so they keep the current constant and they move this tip around. And by the position of the tip, we get an image of what's going on in the surface. So they raster it, they scan it back and forth across this surface, and we get an electronic picture of what's on that surface. And it's on the size of atoms. So in this picture, this is a result of scanning tunneling microscopy. Here we have green iodine atoms on a platinum surface. The blue is the platinum, and the green are the iodine atoms. Now, these are not super clear pictures, but this is the best we can do so far, and it is pretty amazing when you think about how small these atoms are. It's also possible to pick up individual atoms and move them. And so scientists, I know scientists maybe seem boring, but we do have a sense of humor. Sometimes it's a strange sense of humor, but we have fun. So Here, the scientists took some atoms, these are iron atoms on a copper surface, and in Japanese kanji characters, they spelled the word atom with atoms. Isn't that cool? They do stuff like that just for fun. I've also seen IBM. I've seen them say, do your homework in atoms, all kinds of fun stuff. But we do have evidence that these individual atoms exist. This is one form of evidence. So atoms are unbelievably small, but they're still the key to understanding the connection between the macroscopic world that we can see and this microscopic world that we cannot see with our eyes. So the atom is the smallest identifiable unit of an element. We talked about elements a little bit in chapter 1. There are 91 naturally occurring elements, and then there's over 20 synthetic elements. Like just about 2 weeks ago, they came out with, they finally named 4 of the newest elements. The synthetic elements are all man-made, they're not stable, and they fall apart. You're never going to run into them in nature. But, you know, some people get kicks out of making new elements. So on the periodic table up here, any of the elements that are in an outline, they have their symbol in an outline, those are all man-made elements. They're not naturally occurring.